Let us now do a few example problems from the exercise of the surface area of cones. Okay. However, we are not going to do all the problems in the exercise. I'm going to just solve a few select problems from the exercise. The rest of the problems in the exercise are fairly straightforward, where you just apply the formula. I'll do a few samples of the simple problems as well, but the other simple problems can be done by yourself. So I will just focus on the more difficult problems and a couple of simple problems. Okay, so the first question that we will do the question is as follows. We are asked to find the total surface area of a cone given its slant height is 21 meters and that the diameter of its base is 24 meters. So therefore, what is given to us is a slant height L as 21 meters. The diameter of the base, which we will call as D, is 24 meters. So from that, we can calculate the radius of the base. So the radius is half the diameter, so it's diameter divided by 2. So we get the radius of the base as 12 meters. And now we have all the information we need to calculate the total surface area. So the formula for calculating the total surface area is pi r into L plus r. So we have to use pi as 22 by 7. So 22 by 7 into r is 12 meters. So that's 12 into L plus r, which is 21 plus 12. Okay, so we just need to multiply these numbers and we will have our answer for the total surface area of the cone. So that equals 22 by 7 into 12 into 21 plus 12 is 33, and that is going to give us an answer of, if you multiply all these numbers, we get 1244.57, and since it's area and the dimensions are all given in meters, so the area is in meter square. Okay, so the total surface area of the cone with these given dimensions is 1244.57 meter square. Okay, now let us do another example based on the surface area of a cone. So again here we are given the surface area and we are asked to find the radius of the base and the total surface area. So the curved surface area of the cone is given to be 308 centimeters square. The slant height is given as 14 centimeters, and we are asked to find what is the radius of the base and the total surface area of the cone. Okay, so first of all, what is given is the curved surface area, which is given as 308 meters square, and we know the formula for the curved surface area is pi r L, and that is equal to 308 meters square. And from this we can calculate the value of r. So pi is 22 by 7 into r into L is given as 14 centimeters, and that is equal to 308 meters square. So from this we can get the value of r as 308. We will take the 22 by 7 to the other side of the equal, so that will become 7 by 22, and we'll take the 14 also to the other side, so 14 will go to the denominator, so we'll get it as by 14 here. Okay, so this r is 308 into 7 by 14 into 22 divided by 14 into 22. So simplifying this will give us the value for the radius of the base of the cone. So we will have this as 308 into 7 divided by 22 into 14 is also 308. So 308 and 308 will cancel out, so we will have 7 centimeter as the radius of the cone. So radius of the cone r equals 7 centimeters. Now once we have calculated the value of the radius, we have all the information we need to solve the second part of the question, which is to find the total surface area. So the total surface area, I'm going to write the total surface area as TSA. So T for total, S for surface, A for area. So the total surface area is pi r into L plus r, We already know all the values of the variables. So pi is 22/7, that's a constant. R value we have obtained as 7 now, and L plus R, L is 14 plus R is 7, so you will get 22/7 into 7, and 14 plus 7 is 21. 7 and 7 will cancel out, so we will have 22 into 21 as the value for the total surface area of the cone. So we'll get the total surface area as 462 centimeters square. Okay, let me write that properly. 462 centimeters square. Okay, so that's one way of doing it. Another way of calculating the total surface area is, we know the curved surface area, and we can find the total surface area by adding the area of the base circle to the curved surface area. So we also know from our previous session, the total surface area is equal to the curved surface area. Curved surface area, we write that as CSA, C for curved, S for surface, A for area. Okay, so the total surface area equals curved surface area plus area of base circle. Okay, base circle. So the area of the base circle is pi r square, so that will be equal to the curved surface area as given in the question as 308 plus pi r square. R is 7, we have calculated the radius as 7, so into 7 into 7, so that will be 308 plus that's plus 22/7 into 7 into 7. So one of the 7's will cancel out, so we will get 308 plus 22 into 7. 22 into 7 is 154, so we get 308 plus 154, which should be the same as the 462 that we have obtained earlier. So it is just another way of calculating the total surface area. Previously we have just used the formula for the total surface area. Here we have used the fact that the curved surface area is given to us already, and we know that the total surface area is the sum of the curved surface area and the area of the base circle. So we have computed the area of the base circle and added it to the curved surface area to get the total surface area, which we have the same answer as 462 centimeter square. So what I have done on the right hand side here, okay, on the right side, this part of the solution is just an alternative way of calculating the total surface area. So we could use either this method, the normal formula for the total surface area, or we could have used our knowledge that the total surface area is equal to the curved surface area plus the area of the base circle. Okay, so this part is basically another method. Okay, you could use any of the methods and you should get the same answer irrespective of the method that you use, as long as your procedure is correct. Okay, now let us move on to the next exercise problem, and let's try to solve this. Okay, again, it's a basic problem, but we are asked to find some additional things based on the area that we are going to calculate. Okay, so what is given is, we are given that we have a conical tent whose height is 10 meters and the radius of the base is 24 meters. And we are asked to find the slant height of the tent, first of all. So the slant height is L. So from R, the radius, and the slant height of the tent, L. So we know, let's first write what is given. So the given values are H equals 10 meters and R equals 24 meters, and we are asked to find L. So the first part of the question is find the slant height L, and we know that L is equal to R square plus H square under the root, so that's equal to square root of 24 square plus 10 square. So we know 24 square is 476 plus 10 square is 100. So the value of L will be, the slant height will be the square root of 576. Just a little correction, okay, the value of 24 square is 576, not 476, okay, make that correction. That's 576 plus 100, so we get 676 under the root, okay. So the slant height L is the square root of 676, which is exactly equal to 26 meters, okay. So we have the slant height L equals 26 meters. The next part of the question, we are asked to find the cost of the canvas required to make the tent if the cost per meter square of the canvas is rupees 70. So basically what we have to do is we have to first calculate the curved surface area of the tent, and once we have calculated the curved surface area, we have to multiply the curved surface area by the cost per square meter, which is 70. So that will give us the total cost of the canvas to make that tent. So let's do the second part of the questions. For the curved surface area, the formula is pi r L. L is the slant height, which we have already calculated here. So to find the cost of the canvas, we will first find the curved surface area and then multiply the curved surface area with the cost per square meter, okay. So let's do the second part of the problem. So we want to find the curved surface area first. Is pi r L, so which is going to be equal to 22 by 7 into the value of r. The radius is given as 24 meters, so into 24 into the value of the slant height L, we have obtained that as 26 meters over here. So L is 26. So solving this will give us the curved surface area of the conical tent. So we multiply all the numerators here, 22 into 24 into 26, and that gives us 13728. 13728 divided by 7 meters square, okay. That's our curved surface area. In fact, we could divide this 13728 by 7 and get the answer, but we will leave the 7 as it is for now, because we want to multiply the curved surface area with the cost per meter square. So we already see that the cost per meter square is given as 70, okay, which is a product which is a multiple of 7, so that 7 will get cancelled somehow there, okay. So therefore we'll keep the curved surface area as it is here in this fractional form, and then we are given that cost of canvas per meter square equals rupees 70. Therefore total cost of canvas equals the curved surface area into cost per meter square. So curved surface area we have obtained as 13728 by 7 into the cost per meter square is 70. So the 7 goes here 10 times. So we'll have 13728 into 10. So we get 137,280 rupees. Okay. So the cost of the total cost of the canvas is rupees 1,37,280 rupees. Okay. So what we have done in this problem is we were given the cost of the canvas per meter square, and we were asked to find the total cost of the canvas to build the tent. Okay, for that we calculated the curved surface area and then multiplied the curved surface area with the cost per meter square, and that gave us the total cost of the canvas. Okay, now why we use only the curved surface area and not the total surface area? Because the total surface area includes the base of the tent, And normally when we make a tent, the base will be the open ground. We are not going to cover the base with the canvas, okay? So we don't need to put canvas on the floor. So therefore, we are interested only in calculating the curved surface area of the conical tent. And from that, we are able to get the total cost of the canvas. Okay, now let us do one more example problem from this particular exercise of surface areas of the cone. Okay, in this example exercise problem, we are given that that we have a length of tarpaulin. Tarpaulin is the name of the material, okay, which is 3 meters wide. Okay, the tarpaulin, which is of having a width of 3 meters, is used to make a tent of height 8 meters and the base radius 6 meters. And we are asked to find what is the total length of the tarpaulin that is required to make this tent. And we are also asked to take into consideration that when making the tent, there will be some stitching margins and wastage in the material of approximately 20 centimeters, which we will have to add to the total length of the tarpaulin as the wastage component. Okay, so first of all, what we have to do is we are given the height of the tent. Okay, that is the height h. We are given the base radius 6 meters, which is r, and from that height and base radius we can calculate the slant height L. So let us first write down what all is given and what needs to be calculated. So given (8 meters), radius r equals 6 meters. So from this we can find the slant height. Let me write that a bit clearly. So the slant height L is square root of r square plus h square. So that is r square is 6 square, which is 36. H square is 8 square, which is 64. So we'll get that as square root of 100, which is equal to 10 meters. Once we have computed the slant height L, we can now calculate the curved surface area of the conical tent. So the curved surface area, which we will denote as CSA, curved surface area, the formula is pi into r into L. So that's equal to pi is 3.14, because we are given in the question to use the value of pi as 3.14. So 3.14 into r is 6 meters into L is 10 meters. So that gives us the curved surface area of the conical tent, which is equal to 1884 meter square. So when you multiply these numbers, we get 1884 meter square. So we have now obtained the curved surface area of the conical tent. Now, once we have the curved surface area of the conical tent, we want to find what is the length of the tarpaulin required, given that it has a width of 3 meters. So what we have to do is, we have to consider that the tarpaulin is having a rectangular shape, and from that we are going to make our tent. And so the area of the tarpaulin should match the conical surface area of the conical tent. So the area of the tarpaulin will be length into breadth, because it's a sheet rolled in the form of a rectangular sheet. So the width is given. So the area will be length into width, which is 3 meters. So length into 3 meters. And that should give the same value as the curved surface area of the conical tent. Okay, and just make a correction in my calculation here. The curved surface area that we have obtained here, 3.14 into 6 into 10, is, I missed a decimal point here, is 188.4 meters square. Okay, so there's a point there which I forgot to include. So it's 188.4 meters square. So the area of the tarpaulin that we're going to use should be the same as the curved surface area, and we will use that to calculate the length of the tarpaulin. So area of tarpaulin must be equal to the curved surface area of the conical tent, and that is equal to 188.4 meters square. Now, what is the area of the tarpaulin? Area of the tarpaulin will be length into breadth, and we are given that the breadth is 3 meters, so it will be L into 3 meters, and that should be equal to the curved surface area. So now if I'll call the first one as equation 1 and the second one as equation 2, so from 1 and 2 we can write, from 1 and 2 we can write that L into 3 equals 188.4 meter square. So L will be 188.4 divided by 3. So that gives us a value for the length of the tarpaulin as 62.8 meters. Okay. Now we are also given in the question that we have to consider a wastage of 20 centimeters for the stitching margins and wastage in cutting. So the wastage is 20 centimeters. So let's write down the wastage. Wastage equals 20 centimeters, but we have all our other dimensions in meters, so we want to convert this 20 centimeters to meters. So 20 centimeters to meters is, we have to divide it by 100, so 20 divided by 100 meters, so we get this as 0.2 meters. So now we have to include the wastage length in the total length of the tarpaulin that we have calculated based on the curved surface area. So the total length of the tarpaulin is total length is equal to the length L that we have computed plus the wastage. So that is basically 62.8 plus 0.2, which is 63 meters. So we have now obtained the length of the tarpaulin required to build this tent of the given dimension. So what we did was, we first calculated the curved surface area of the conical tent, and we used the fact that the area of the material that we're going to use to build the tent should match the curved surface area of the tent. So from that we were able to calculate the length of the tarpaulin given its breadth or width. So we got the length as 62.8 meters based on the curved surface area, and then we included the wastage length to the total length that we computed, and that gives us a total length of the material required for the tarpaulin is the length computed based on the area plus the wastage length, and we get that as 63 meters. So we will stop here for now, and we will continue with our some more examples of the surface area of cone, a couple more examples before we move into the surface area of spheres and hemispheres in the subsequent videos. So in the next video I'm going to do some more examples of the surface area of cones.